Hello and Assalamualaikum. My name is NURAIN binti AZHAR from 4 BEKM S1. I present about introduction for parking lot system. Over the years, large number of new registered vehicles were reported compared to the previous years. Based on the statistic, the current transportation infrastructure and car park facilities are deemed insufficient in sustaining the influx of vehicles on the road. Problems such as traffic congestion, pollution, and environmental issues inevitably crops up. As a measure, a micro-simulation technologies are developed which allow the patrons to know the exact number of parking space available and identify the presence of a car in the parking lot. The patrons are able to avoid car parks that are fully occupied and locate vacant parking spaces with ease elsewhere. This is the similar example of parking lot system for our project. From the figure, the green light shows the number of vacant parking spaces in the parking lot, so the drivers can see if the parking lot is fully occupied or not before they decide to enter the lot. For our PBL, EZ60AK is used to recreate the parking lot situation. However, the light signal will be replaced by an automatic counter that will display the number of automobiles that enter and exit the parking lot. To illustrate, the counter will display 100 to alert the drivers that there are 100 available parking spaces in the lot. Then the number of the display will decrease or increase accordingly if the sensor senses the presence of the car. If the lot is full, the automatic counter will be adjusted to reflect the available parking spaces. This system is effectively save time and improve on-site parking system.
Assalamualaikum. My name is DALINIE EMYSHA from 2 BEKM S2. Today I will explain briefly about our PBL parking lot system. So basically, our PBL was run in the EZ60AK simulation. The EZ60AK simulation uses assembly language which is easy to us to understand the language, and it is simulated using output window simulation. The function of the system, the parking lot system was designed to improve the flow of the current situation where the traffic congestion on the norms in the cities. And it was not on the highway but in the searching for the parking in the parking lot in the mall itself. Mostly the parking lot system was in the mall because it is take time to searching for the parking. Thus, a specific car lot system must be invented to avoid such problem. So this is the illustration of our PBL project. The counter will always update the availabilities of the parking system, and it also have the light. Either it is green for available parking and red. This is the flowchart of the parking lot system. When a car enters the parking lot, the counter will show the number of the cars. If the availability is more than 0, the gate will open and allow the cars to enter the parking lot. But if the counter show the availabilities of the parking lot is not more than 0, the gate will not be open. So this has shown that our parking lot system was very effective. It has proven our parking lot system will not waste our time. Is there the availabilities? Door will open. Is not, the door will close. So to make our project-based learning success, we use the EZ60AK editor. This is the example how the EZ60AK editor was look like. The title. This is actually the comment before start our coding. Example, the output that we will get. So let we see here. When the car is entered, the counter will show the number of the availabilities. If there more than 0, the gate will open and it allows the car to enter the parking lot. And if the car already get the parking, the counter will update the current availabilities of the parking system. So we have seen the roughly about our project-based learning. We have seen the details about it. We have seen the illustration about it. We have seen the flowchart, how the system works. We have seen briefly about the editor and how the outputs look like. So that's all for me. Thank you.
Selamat sejahtera to Dr. and my friend. My name is Teki Ng from 2 BEKM S2. Now I'm going to show the code that we have done for our parking lot system. So first, we're going to initialize the moving object, which is the door, car 1, and car 2. These 3 objects are the ones moving in this program. And then we're going to show some greeting messages by displaying the message. So we're going to use the command JSR jump to subroutine draw text 1, which is mean that the JSR is used to so that the EZ68K will jump to draw text 1 and store the return address into the stack. So when this command is executed, it will jump to the below part where the draw text 1 is. Here, these are the commands used to display the message. And the first one is to move the value of 95 into data register D0, and the load effective address is used to load the message of text 1 into the address register A1. And then these commands are used to set the positions of the message, and this is used to execute or to display this line of message. Then we're going to RTS, we're going to return to the earlier part here. Then we'll go to the next one, which is delay. We're going to delay for a while, and then it's here. We're going to delay for a while, and then it will display the next message in the second line. After this message, and this will display in the second line. And that's why the command for draw text 1 and draw text 2 is a little different from the value to be moved into the. We're going to see for the draw text 2. Is the same, only for this line. This one is to place this text at the first line, and this is to place the second message at the second line. And as well as you can see for the draw text 3, the next message will be displayed at the third line. So the only difference between the coding about the draw text 1, text 2, text 3, text 4, and only for this line, where it's going to display in the first line, second line, third line, and fourth line. Then so after we display all these messages, we will clear out the screen and jump to the begin, where we're going to count down for our program to start. And it will return to here again, and it will jump to set. So the set, we set the initial counter 0 to the data register D5 for the door opening, and then it go to the test here, where it will set the conditions to 100 steps into the data register D5, and it will jump to loop here. It will jump to loop, and it will execute the command over here until the 100 step is reached. So at loop over here, it will display the title at the output window, parking lot system, and display the number of available parking slot, which is 5. And this is the part where the parking lot scene, which is the line, will be drawn out. And this is so just now the command JSR parking lot scenes, which is jump to the parking lot scenes. So here the outer line will be drawn to show out the scenes of the parking lot. So for the first outer line, we're going to set the aqua color to data register D1. Then we're going to set the pen color and execute it. And this is the command to draw the line. And lastly, we will execute it. Then when this command are executed, there will be the first outer line, and same as well as the second outer line, third outer line, fourth outer line, fifth outer line, and so on. And we also draw for the counter status. And the box 1 to box 6 is to represent the parking lot. Then after all this have been drawn out at the output window, it will return to the subroutine. Here. Yeah, here. And then these are the commands for the door to open. And after the 100 step is reached for the looping, it will jump to moving, where it's going to set the 0, the initial counter, to the data register 5, and then go to test 2, where we set the value of 220 into the data register D5 and jump to loop 2 here, where this loop is going to run until it reaches the 200 step and jump to closing. So these are the command for the car to move in. So after that, when 200 step is reached, it will jump to closing, where it is similar to the opening. We will set the initial counter for, and then it jump to test 1, and here, and where it will set the 100 step into data register D5 and then jump to loop 1 here to show the movement of the car into the parking lot. So earlier part, it is 5 parking available. When the car have moved into the parking lot, it will become 4 available parking lot. So these are the command used to make the box or represented as car to move into the parking lot, and this command is used to close the door and so on. So after 100 step is reached, it will jump to second round. So second round is same as the one that I explained just now, because second round is the one where the second car move into the parking lot. So the command is almost the same, but the only thing is when the second car have moved into the parking lot, it will jump to subroutine done, where we're going to show the message that our program have end. And thank you for watching and have a great day.
Assalamualaikum warahmatullahi wabarakatuh. My name is AFIQ bin Muhammad Noor, and I'm here to show you the output of our coding simulation. Okay, as you hit the button run here, or you can hit the F9 on your keyboard. Okay, first you will see, the first thing you will see is this 4 line here, and then after you keep running the simulation, you will have the 3, 2, 1 countdown and the start. And after that, you will see the small rectangular color box represent the car. Okay, then you can see here all these little lines here. This rectangular aqua box represent the empty parking spot system. This rectangular box here represents the empty parking lot, and the red line here represents the door, and the yellow car here represents the car itself, and this light gray box represents the status counter of how many empty parking spots left. Okay, we will continue the simulation. You can see here, when there's car outside of the door will open and letting the car to go park at any empty parking slot. And then after the car done park itself, the center counter will change from 5 to 4, and the red door will close. If there's another car outside the door, the door will open for the car to let the car go inside the parking spot, and the status counter will change from 4 to 3 to indicate the number of empty parking spots left. After that, you will read with N, and thank you for watching and have a great day. Okay, this is the output of our coding simulation. Thank you.